Okay, so I've gone through how we're going to be calculating the values. Now we're just, so this is continued 3. So the first thing to do was to work out the first moment of the first moment of inertia of the section. So there are a lot of ways to do it. Let's just draw the section down here. So as we said before, the section is going to have a neutral axis, and the neutral axis is going to be along that line here. So just call that neutral axis, and then we're going to be, our definition of y is going to be at 0 at the neutral axis. So we're going to have this area and our chord, so we know that this is going to be 300 millimeters, and we know that this is going to be 20 millimeters. So area 1 or A1 is going to be equal to 300 millimeters multiplied by 20 millimeters, and that's going to work out to be let's just keep it that way, 6 times 10 to the 3 millimeters squared. So we've got what I'm going to call area 1, which I will show you there, and then the second area is going to be this area 2. So let's say area 2, and then the depth of this area 2 is going to be 560. So we know that area 2 is going to have a depth of, best place to draw that, okay, let's just draw it there. So the depth of area 2 is going to be 560 millimeters. So 560 plus another 20 plus another 20 is going to bring us to 600, and so the area 2 is just the web there, so 560 millimeters, and then the thickness of this area 2, the thickness is going to be 12 millimeters. So area 2 is going to be equal to 560 millimeters multiplied by 12 millimeters, and that is going to work out to be 6.72 times 10 to the 3 millimeters squared. So we've now got our area 1 and we've got our area 2. Now for area 1, let's work out the second moment of inertia. So if we had area 1, which is going to be like that, and let's work out the second moment of inertia about its own neutral axis. So along the area 1 has its own neutral axis, and the second moment of inertia of area 1 about its own neutral axis is going to be 1 over 12 times the breadth times the depth cubed. So the breadth is going to be 300 millimeters, and then the depth cubed is going to be 20 millimeters all cubed, and that is going to work out to be about 2 times 10 to the 5 millimeters to the 4th. So we've got the second moment of area of area 1, and then 1, 2, 3, 4, 5. So then we've got the other section there, and then that has its own neutral axis there, and of course that neutral axis also coincides with the neutral axis of the composite shape, but let's just leave that for now. So so that's going to be 1 over 12 times the breadth, and in which case the breadth is going to be is going to be 12 millimeters, because that's going to be the thickness. So it's going to be, and then the cubed portion is going to be the total dimension in the downwards direction. So 1/12 BD cubed so that's going to be 560 millimeters, and that's going to turn out to be 1.756 times 10 to the 8 millimeters to the fourth. So now having done that, we now want to work out the second moment of area of the whole section. So the second moment of area of the whole section is going to be, so we'll call that I, second moment of area of the whole section. So it's going to be the second moment of area I1 about its own neutral axis, and then it's going to be and then onto that you are going to be adding the area of the first section of the of area 1, and then you're going to be multiplying it by that distance there. So that distance is going to work out to be 300 millimeters, since the total depth is 300, less half the thickness of the top bit, which is going to be 10 millimeters. So 300 minus 10 is going to be 290. So that's going to be multiplied by 290, and the 290 millimeters must be squared. So that's going to take care of the top area. So let's just put a box around there. Now, so that takes care of that portion there. Now we have another portion down here, so we could just put 2 there, because we know that it's going to work out to be the same, since the area term is squared, area times the distance squared. So in that case it will be negative 290 squared. Or if we weren't happy to add the 2, we could just add it on as an I1 again, plus A1 times, being totally correct, negative 2 millimeters squared. So that's going to take care of that portion. So, and that one is going to take care of there. So exactly the same technique with the with this member here, but with that member there, since the neutral axis coincides, i.e. the position of that neutral axis relative to the web is the same as the neutral axis for the composite section. So that's going to be plus I2 without any change. So I2 could be that one there, and then we could add on another I2, which would then become that one. So there are a lot of different ways of doing it, but if we worked out the I, just put an equal sign there, if we worked out, if we went through the maths and worked out that calculation, that's going to turn out to be 1.361 times 10 to the 9 millimeters to the fourth, which is going to be the I of the composite section, or the I of the box section.